Welcome to multiple choice question 12 of the 2009 Mathematical Methods Exam 2. In this video, we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on, I'd just like to point out that the use of a CAS calculator is not really appropriate for this question. So for question 12, we have a transformation T, which maps from R2 to R2. So it just means we start with a Cartesian plane, we end with a Cartesian plane. And the transformation T that maps the curve with equation y equals sine of x onto a curve with an equation y equals 1 subtract 3 sine of 2x plus pi is given by one of the following transformations. So I'm going to show two methods in here of how to do this problem. The first method will be just by inspecting the rules and a little bit of manipulation, and the second method will be using mapping. So for our first method, I'm just going to set up y equals sine of x, and we know that it maps to the equation that will be y equals, and then I'm just going to do some slight rearranging of that second equation. So the first thing is it's minus 3 times sine, and then inside the brackets, I'll actually rearrange this to be 2, and then another set of brackets where we can have x plus pi on 2. So hopefully you can see if you expanded those brackets back out, you'd just get 2x plus pi. And then the other thing we can't forget about is the plus 1, which I'm just choosing to put at the end, as that may be a more familiar form for many of you. So next we can identify, and I've color-coded 4 things that have happened to this rule. So the first one, which is the negative 3 that multiplies sine, we need that to be a dilation by a factor of 3 from the x-axis and a reflection over the x-axis. So in our matrix, we need negative 3 to multiply y. So we need a negative 3 here, a negative 3 there. So they're the two options that we can really hone in on. And now to get that 2 that's multiplying the x plus pi on 2 in this equation, we actually need a half to multiply x. So this half here and this half here would be okay. So we've already essentially got down to the point where it needs to be option D for this question. And just to confirm that that is the correct answer, to get the x plus pi on 2, we actually need a minus pi on 2 in our matrix system, because that's a translation of pi on 2 units in the negative x direction. So we need negative pi on 2 in the matrix. And then that plus 1 at the end just needs to be this plus 1 at the end of this matrix equation. So the only option that's correct is D. Now I'm going to do this question, but using a different method. So I'll just bring up a blank version of the question. And now we're going to use mapping, or perhaps what I might call reverse mapping, to do this problem. So we're going to set up in a similar way. We're going to say y equals sine of x has mapped to, but this time I'm going to put dashes on the x and y terms. So it's going to be y dash equals 1 subtract 3 sine of 2x dash plus pi. And then what we're going to do is we're going to rearrange the second equation to get as much on the y side as we can. So we're still going to have y equals sine of x is mapping to, but now I'm going to do y dash, and I'm going to subtract 1 across and divide by the negative 3. And that will equal sine of 2x dash plus pi. And we can't get anything else onto the y side easily, so we leave it in that form. And then what we can do is we can identify that this y is in the same position as the y dash subtract 1 all divided by negative 3. So therefore we can say y equals y dash subtract 1 over negative 3. And we can also identify that this x, which is inside sine of x, is in the same position to the 2x dash plus pi, which is inside sine of x on the other side. So therefore, we just can say that x is equal to 2x dash plus pi. In this particular method, we want to now get the dash terms by itself. So for the equation involving y's, I'm going to start by multiplying both sides by negative 3 and adding 1. So that will give us y dash is equal to negative 3y plus 1. And now for the equation involving x, we're going to start by subtracting pi and dividing by 2. So x dash, getting that by itself, is equal to x subtract pi divided by 2. And then what I'm going to do here is I'm just going to split up that fraction so that we can actually write it as x dash is equal to x over 2 minus pi over 2. Now, if you wanted to, you could put it into mapping notation. So x, y has map 2, and for x, it mapped to x over 2 minus pi over 2, comma, negative 3y plus 1. And we now need to look for the matrix that allows this to happen. So again, we want a half to multiply x, and we want to subtract pi on 2 off that. So that's the half here that we identified in our other method that was correct, and the negative pi on 2, which is correct. And we also need a negative 3 to multiply y, so that's this negative 3 down there, and we need to add 1 onto the y terms, so that's that plus 1 there. So using this reverse mapping method, we can also identify that D is correct. From the examiner's report, we can see that this question did challenge a number of students, with 61% of students getting this question correct.